Hey guys, we're speaking to you here from Alexandria, Egypt. Thank you so much for giving us the opportunity to show you our work. And we're going to start off in our presentation by speaking about our team a little. So Tachyon was founded in 2016 as a team that is interested in human-powered vehicles. We participated in the competition twice, in 2018 and 2019, when we had the 10th place in the design competition and the 30th in the overall scoring. In our presentation, we'll be discussing three main headlines. The first one is the design updates, at which we'll be talking about the modifications that we made after submitting our report. While the second headline should be the RPS testing, and the third is the performance tests, which is mainly just us proving that our vehicle applies to the rulebook. Concerning the design updates, three modifications were made. The first one was that in the chassis, the main rod was a rectangular cross-section, as you can see on the picture on the left, but after performing experimental pedaling test, a deflection occurred, so we had to change it to a circular cross-section, as you can see on the picture on the right. Another modification was the rising curve in the fairing. It was first designed to cover the wheel rod, as you can see on the picture on the left, but it would then cause a bit difficulty fixing the chassis to the fairing, so we decided to shift it a bit before the wheel rod itself. The third modification was the steering angles. They were modified depending also on conducted performance tests. The camber angle was depleted to 0 degrees and the toe angle was changed to 10 degrees. The kingpin inclination applied to our old vehicle was removed as the driver sensed an annoying friction during the endurance test, while the indirect steering system, which was aimed in the design period, was changed to a direct system as it was much easier to manufacture. One of this year's additions that we also wanted to highlight was the damping system we added, as we encountered difficulties moving over the pumps in the endurance test in our last year vehicle. So a spring damper with a carrying load of 700 pounds was added as a rear wheel suspension. Next, we'll be talking about our RPS testing. Its objective was to ensure that our vehicle's RPS applies to the rules of the ASME Rulebook 2020. So we performed the test by adding a force of 2,670 newtons on the top of the RPS and also 1,330 newtons on the side of the RPS. And we found the deflection to be only approximately 1 millimeters, so it would be safe for the driver to drive the vehicle on this chassis. But please note that these pictures and the following videos will be from last year's vehicle. We didn't have the ability to film the tests we made this year due to the pandemic situation. As for the attachment points around the RPS, we tested their safety level by flipping over the vehicle with the driver inside as shown, with a positive result of the belt being properly attached to the driver's body with nothing touching the ground. Last but not least, we'll be talking about the performance tests. Two performance tests were made to also ensure that our vehicle applies to the competition rules. The first one was the brakes deceleration test, which was made by measuring how long of a distance the vehicle takes until it fully stops from a speed of 25 kilometers an hour. The test was made as shown in the video, with a minimal braking distance of 6 meters. The second test was measuring the vehicle's turner radius to ensure that the steering system applies to the rulebook as well. The test was made and the turner radius turned out to be 6.15 meters, which is far less than 8 meters as shown in the video. We wanted to conclude with some of the main specs that might be necessary to talk about, such as the vehicle's weight, which turned out to be only 23 kilograms. Both the aluminum chassis and optimized fairing design gave us this relatively small value. Another important spec was the aerodynamic coefficient of drag of the whole vehicle, which was calculated through the CFD analysis we conducted on ANSYS Fluent software. The drag coefficient turned out to be 0.64 as mentioned in the report, with a relatively good kinetic energy dissipation behind the vehicle, with respect to our early fairing designs in the design phase. We also wanted to note that the fairing was not the only component that was analyzed on a simulation. but rather most of the whole vehicle components were thoroughly studied in finite element analysis simulations. Thank you so much for listening. We would have appreciated your questions and comments in a live presentation, of course, but we really hope to see you next year at a safer and healthier global conditions.